So our next lesson is Chapter 1, Lesson 4. Now in Chapter 1, Lesson 4, we actually have two lessons basically put together. We have the GCF, and then notice I put an addition sign, which I'll explain here in just a moment. But a very brief introduction on GCF takes us back to our 1.1a when we got into looking at what numbers go into. We talked about prime and composite, right? So when we look at prime and composite, we were talking about what factors are there in specific numbers. If a number has two factors, then we knew it was prime. If it had more than two factors, if it had at least three, then I know that it was a composite number. Well, being able to find those factors is what's important in this lesson. Now, this is basically opposite of what we just did. So in our last lesson in 1.3, we were looking at the LCM, the least common multiple. And this is just the opposite, because now it's the greatest common factor. The addition sign means that we have that second lesson, which I mentioned. So in 6th grade, we look at several different properties. And properties are kind of like in science when we talk about with scientific laws, things that are true no matter what. Numbers interact in specific ways, and we can set up numbers in specific ways according to these properties in mathematics. So the other half of this lesson is the distributive property. Now that might be new for you, and it really seems kind of confusing at first when you see it, but please don't let something new and different defeat you as being a mathematician. You can learn math as long as you're willing to participate with me, and even if maybe you don't get it, you ask me questions, I'll work with you as we become better mathematicians. So we're going to start with looking at the definition of the words or the letters GCF. It's the greatest common factor. So the idea of greatest just means largest. I think we all understand that without any kind of problems. Common means that they both have it. Now, we could have 3 numbers that we compare, 4 numbers compare, so on and so forth. But in common means we took 16 here in the book, and they gave us all the factors of 16, all the numbers that go into it evenly. And then we took 20, and we found all of the factors, all the numbers that go into it evenly. Now, the common means 1 is listed in both of them, and 2 is listed in both of them, and 4 is listed in both of them, but the other numbers are not in common. So we only have 3 common numbers between 16 and 20 that are factors. The last step then is it has to be the greatest. So if I have the greatest and it is indeed a factor, then I'm looking at the 4 to be the greatest common factor that they both have. Putting that into motion then, in this first example, then they're talking about cutting strips of wood and how can I make sure that I have an even number. It says Jim is cutting 2 strips of wood to make a picture frame. The wood strips measures 12 inches and 18 inches. He wants to cut the strips into equal lengths that are as long as possible. Into what lengths should he cut the wood? So to find that out, to make sure we have the same number of pieces, then we would have to find the factors of 12 and the factors of 18. So I've mentioned this previously already in the first week of school. When I look at the factors then, some people will go in their counting order. I try to be a little bit more systematic so I make sure I don't miss any. So I always start with 1 and the number itself, because 1 is the lowest factor of any number, and itself is the highest number that is a factor of any number. So I know I'm going to have 1 and I'm going to have 12. Those are already in your book. Then I come back to the 2. That's my next counting number. Does 2 go into 12 evenly? It does, because it's even. So I'm going to have a 2. And then I ask, how many times does 2 go into 12? If you don't know, if you're not really good at your multiplication facts, it's something that's going to be our goal in math is to become better at as a class. But you can get your handy dandy calculator and type it in. 12 divided by 2 equals. And you'll see that it's 6. That's going to go over here. So the larger ones are always going to be on the right. The smaller ones are going to be on the left. And then we're going to meet in the middle. My next counting number is 3. How many times does 3 go into 12? Well, 3 times 4. and those are consecutive, side by side, counting numbers, so I know I've included all of the factors that I need. On factors for 18 then, I have, you're going to ignore that because I'm going to ignore that. I don't know why that keeps popping up. But I know I have 1 and the largest number that's a factor. And the largest number that's a factor is that number itself. So I have 1 and 18. Then I go to my next counting number, which is 2. 18 is even, so I know 2 will go into it. So I have 2 times what? Well, 2 times 9 is 18. How about 3? Yeah, 3 goes into 18. So I'm going to have 3 times 6, that's 18. Now, I know that's all there is because that's the spaces that are there, but I would keep going and asking that question, does it go into it, until I get to a number that's already there. So after 3, I'd have 4. Well, 4 doesn't go into 18. 5 doesn't go into 18. 6, yeah, it's already there. So I have all of my factors of 18. Then I go through those steps, greatest and common. So I look at the ones that are in common. I have a 1 that's in common, a 2 that's in common, a 3 that's in common, and a 6. Well, I'm looking for the greatest one, the largest, so 6 is my GCF, my greatest common factor between 12 and 18. So he would need to break these up, each of them, into 6 pieces, so I have the same number of boards out of the 12 and the 18. All right, so now we looked at the Venn diagram with the LCM. I can also use the Venn diagram for the GCF, the greatest common factor, but it works a little bit different. So on the LCM, we found the factors, that are in the middle that were the same. And then on the outside were the ones that left. It's the same setup for the GCF. So when I look at 12 and I talk about finding the factors, then I can tree it like we did with the prime factorization. So in prime factorization and I tree the 12, then I'm going to break it down and I'm going to start with my first prime number that I use. My first prime number that I use is a 2 because 2 goes into 12. How many times? 6 times. Now I tree only the 6 like we talked in lesson 2 because 2 will go into it and 2 is a prime on my list, so I leave it alone. So I'm going to tree the 2 or the 6 because 2 will go into it 3 times. So that gives me my prime factorization for 12. I have to do the same thing. Well, I'm going to fill in my multiplication problem. Then I have to do the same thing for 18, finding the prime factorization. So once again, just as a reminder, as we learned in lesson 2, prime factorization is finding all the base primes and then making a multiplication problem out of them. In 18 then, I tree 18. 2 will go into it because it's even, so that's where I'm going to start for my list. So 2 times what? Well, that gives me 2 times 9. Then I'm going to tree the 9. 2 won't go into it, so I'm done with the 2. But my next counting number is 3. And 3 will go into 9 evenly 3 times. So I have 3 times 3. So my primes are what's left at the bottom of my tree branches. So I have a 2, a 3, and a 3. So I fill in my multiplication for prime factorization. I have 2 times 3 times 3. In the middle of my Venn diagram are the ones that are in common. Well, what do I have in common? I have a 2 and I have a 3 that are in common, right? So 2 and 3, 2 and 3. So that's going to be in the center of my Venn diagram. Everything else that's left are the ones that are left alone. So I still had a 2 over here, so I have to include it. And I still had a 3 over here, so I have to include it. Now when I talk about the greatest common factors, LCMs were, I multiplied then 2 times 2 times 3 times 3. So this is just greatest common factor. So if I'm going to do the Venn diagram, and I'm doing greatest common factor, all I focus in on is the center. So that tells me if I multiply 2 times 3 from the center of the Venn diagram, which gives me 6, then I know that my greatest common factor is 6, which is what we showed before by listing them out. The distributive property is the thing that's new. Now, when there's something new, I usually get a handful of students, and it's usually the ones that have missed some things in previous years and they just think they're a terrible math student. I never really had a terrible math student. I've had several math students that have come to me that they just missed stuff, maybe it was even as basic as the 3rd grade, and it just kind of got skipped and they tried to build upon it. You know, if you've ever tried to build a house and you only had half of the foundational bricks, your house would never be able to stand. It's kind of like trying to do math if I've missed some things over the 3rd, 4th, 5th grade years. So one of the things I strive to do for each and every one of you is to find out those little pieces that you're missing, make sure you understand them so your foundation is nice and strong, because I want you to be successful in math and I want you to understand math before you leave my class, and then 7th, 8th grade and high school becomes so much easier. But when we get to new things, if you're one of those people missing a couple of things, they feel defeated and they just say, I just don't get it, I just don't understand, and they shut their brains down. Well, don't shut your brains down. Actually follow along and pay attention and listen to what I'm saying. Maybe pause this and rewind it and watch it 2 or 3 times after I'm done explaining it so you can see what I'm talking about and so you can understand it. Then we will do some practice problems and walk through it as well. So you should have a pretty good foundation on this idea. So when I talk about the distributive property, what they're saying is, I can take a 5 and multiply by 2 numbers inside of a parentheses. So like addition, I have 8 plus 6. I can multiply them together and have 5 times 8 and the 5 times the 6, and it has the same value. Well, what does that actually look like? So when I look at that then, I also need to understand that multiplication can be seen a couple different ways, and we'll go over this several times throughout the year. But I can have that multiplication sign, but sometimes there's a set of parentheses. And when we get into order of operations, we find out that that means the things inside the parentheses have to be done first. But if I look at the distributive property, it means that I can multiply, and that means multiply because the number is touching the parentheses, into each of those numbers. Now when I say into each of those numbers, that's exactly what I mean. That's what the book has done for you, and then I show you in this example, it's the same thing. I can take 5 times the 8, the first number inside of the parentheses, and that's where my 5 times 8 in parentheses over here comes from. And then I would take 5 times 6. Up here it says 5 times 6. And that's where my 5 times 6 comes from inside of those parentheses. It helps me then solve for the math problem. So 5 times 8, and I write it down. I'm going to keep it as addition because that's what it shows inside the parentheses between the 8 and the 6. So then I would take 5 times 6, and I would write it down. And then I can go through and I can solve those problems. Well, 5 times 8 is 40, and 5 times 6 is 30. And if I add those together, then those would have to equal 70. Okay? So the distributive property is going into numbers. However, I can also do it backwards. So what I mean by that is if I have 40 and 30, then if I think about what the greatest common factor is between 40 and 30, I can break it down and create a distributive problem called a product. So when I look at it, I would think, well, my greatest common factor is 5. So I know 5 would go into both of those numbers evenly. So if I know I'm going to take 5 out of it, well, that means that when I talk about 40 and I think about my multiplication facts that we started learning in 3rd grade, that's 5 times 8. And if I know that 5 is going to come out of the 30, then my multiplication facts tell me that that's 5 times 6. So I just set those off by themselves inside of parentheses. And then when I see those, I see, well, there's a 5 that I'm multiplying by each of those as the greatest common factor. So I'm going to take the 5 out and set it off by itself. Anything else that's left then, I'm going to keep together. So I have an 8, I have an addition sign, and I have a 6. So I'm going to set those off by themselves inside of an addition and parentheses. So once I have that, that's my distributive property. But then when I solve them, we would see that I would get the same answer. All right, so when I look at this example, it says use the GCF, greatest common factor, and the distributive property to express 36 plus 27 as a product. So once again, showing a product with the distributive property is going back and using a greatest common factor to multiply by a set of parentheses. So as I'm getting ready to do this, if you're thinking, wow, I really didn't get what he just said. So you can pause the video, you can rewind the video, and go back through this whole section. There's nothing wrong with that. You're on your time watching these videos, and what you do is going to help you become a better math student, which is all of our goals. So as I do this, then I have to know what the GCF, the greatest common factor of 36 and 27 is. All right, well, in order to do that, I have to list the factors so I can see there are common factors, but I need my greatest common factor. So I start with 36, and once again, I do it to where I list my smallest one and my largest one, and then I go back and forth between small and large numbers until I get all of them listed. So I know on 36, I'm going to start with 1 on the left, and then I'm going to list 36 on the right. And then there's several of them on 36. So I have 2 and 18, 3 and 12, 4 and 9, and then 6 is by itself. Why would 6 be by itself? See if I can get that out of the shadow. I can't, the light's right on it. Well, 6 is right by itself because 6 times 6 is 36. So when I'm doing my factors, there are times that numbers are going to be by themselves because it's a multiplication of doubles type of problem. So on 27, I would do the same thing. I have to have my smallest number all the way over to my largest number. So I would start with 1 and go to 27. My next counting number is 2, and 2 doesn't go into it because it's not even, so I go to 3, and that's 3 times 9. Now I could use all my next counting numbers, but between 3 and 9, that goes from 4 to 8, none of those go into 27 evenly. So that leaves me with common factors of 1, 3, and 9. It has 3 common factors, but I have to use the largest, the greatest common factor, which is the 9. So if I'm going to use the 9, then I can begin to set up my distributive property product. 9 is going to come out of 36 and 27. So if I know I'm going to have 9 by itself, which is what they're showing you here, then 9 times what equals 36? Well, that would be a 4. And then 9 times what is 27? Well, that would be a 3. So I can see where I have now 36 broken down into a math problem of 9 times 4. Still have the addition in between them, and now I have a multiplication problem of 9 times 3, because 9 times 3 is 27. I broke the 27 now. Now what do I have in common? I have the 9 in common, so I'm going to distribute the 9 out of both of those parentheses. So from both of them, that 9 is going to come out and be set off by itself. And that's where this next line comes from. Notice the 9 and the multiplication sign. Now, you don't have to have the multiplication sign because, once again, a number touching parentheses means multiplication automatically. But either way, it's correct. So when I take that 9 out then, and it's by itself, I just keep what's left inside a set of parentheses. There's a 4 left, there's an addition sign that's left, and there's a 3 left. So I've created my distributive property product for this problem of 36 plus 27. Now at this level, it's asking you to check your work. All right, we can check our work. How would I check my work? Well, the first thing it says to do is add 36 and 27. Basic addition, right? You can even use your handy dandy calculator. You're going to find out when I add those two together, I get 63. All right, so if I add those two together, then what they're saying is I'm also going to solve for this problem. I'm going to solve for my distributive property that I just did. I have 9 times 4 plus what? So checking my answer, I have a 3 inside of there because that was the answer I came up with. All right. So inside of my parentheses, that tells me I have 4 plus 3. What is 4 plus 3? Basic math, right? 4 plus 3 is 7. So that's left with, well, 9 times 7. Multiplication facts from 3rd grade. 9 times 7 is 63. So I've seen that by solving the distributive property, I get the 63. And if I would just start by adding those two numbers together, I get 63. The answer is not 63. I've checked to make sure that my answer of my distributive property is indeed equal to 63. Because remember, they asked me to use the GCF to find the distributive property product, so that is my answer. 9 times, in parentheses, 4 plus 3. All right, so as we go on then, underneath it, number 1, it says explain 2 ways to find the GCF of 36 and 27. Now remember, in these type of questions, I only want one. That's what I need you to be able to do, is remember one way to do a math problem. Do you need to remember 2, 3, 4 different ways of doing it? No. But there are 2 ways that you could do it. The first one that you could write down, list all of the factors and match the largest that is in common. So that's what we're doing up here. I'm listing all of the factors and then looking for the largest that they have in common. Well, what's the second way of finding the GCF? Well, the second way was the Venn diagram. So I would find my prime factorization of each number and multiply the matching factors. So if you remember on the Venn diagram, we had just the 2 and the 3 in the center oval of the Venn diagram to show that those 2 matched, that they were in common, and 2 times 3 was the 6. We left the other numbers by themselves. We only use those if we're doing the least common multiple. So those 1 or 2 ways, and you just need to have one of them. And if you don't have one of them written down, pause the video now. All you have to do is hit your space bar and then come back to it to continue on. All right, so now this first set says just to list the factors of these different numbers. So, and then find the GCF. So this is list the factors of 12 and 20 and circle the GCF. So 12 and 20. So when I go through it, once again I start with my smallest one, which is always going to be 1. 1 is always a factor of any number. And then I list the 12 out to the far right because that's the largest one. So I know I have 1, and 1 times 12 is 12. My next counting number is 2. 2 will go into 12 because it's even. So I'm going to take 2, but 2 times what? Well, 2 times 6 makes 12. So it goes out to the right. My next counting number is 3, and 3 does go into 12. How many times? Well, 3 times 4, right? So my next one is going to be a 4. Those are consecutive, meaning side by side. Counting numbers, so I know I have all of them listed. I do the same thing for 20. I start with 1 because it's always going to be a factor, and I list the number itself out to the right because that's the largest one. So I have 1 and 20, and then I go to my next counting number after 1. 2, 20 is even, so 2 will go into it. 2 times 10, right? So it's going to go out to the right. 3, well, 2 plus 0 is 3, so 3 doesn't go into 20. 4, yeah, 4 does go into 20 because it's 4 times 5. So I list 4 and then 5, and those are consecutive counting numbers, so I know I have them all. Once I have them all, I don't need to circle all of the factors that they have in common. I just need to focus on the greatest, the largest one that they have in common. So here's a 12, and it's not below. A 6, it's not below, but the 4 is listed below. So my greatest common factor between 12 and 20 is going to be 4. We're going to do the same thing for 2, 3, 4, and 5. 16 and 18 then. What are my factors of 16? Well, for 16, I start with 1, and then I list the largest number, which is 16. Then I go to 2. It is even, so 2 goes into it. How many times, though? 2 and 8. How about 3? 3, 6 plus 1 is 7. 3 doesn't go into 16. 4? Yep, but I only have to list it once. Now, if you want to list it twice, that's fine. Okay, I'm not going to count it wrong if you list it twice. There's more than one way to do a math problem, but I usually just try to list it once so I don't get confused. Okay, but it is 4 times 4, so it's a multiplication of doubles. 18, then I start with 1 and 18, right? The smallest and the largest that I can have as factors. It's even, so I know I have 2. Well, 2 times what? 2 times 9 is 18. How about 3? So maybe you don't know the multiplication facts of 3's, but if I add my distributive property from lesson 1.1 or 1.8, then I would take 1 plus 8 is 9, and 3 does go into 9, so it is a factor. So I'd have 3. 3 times what? Well, that's 3 times 6. 4? No, 4 doesn't go into 18. 5? That doesn't work. It doesn't end with a 0 or 5. 6? It's already listed up there. So I have all of my factors. Now I'm looking for my greatest common factor. So I look at 16. It's not down below. 8? It's not down below. 4? It's not down below. 2? Yeah, 2 matches up. So that is my greatest common factor. So here's a question. Could you have 1 as the greatest common factor? Absolutely, I could. Okay? So if it doesn't have any other factors other than 1, then 1 would have to be my greatest common factor. On this line then, I'm going to put my greatest common factor, which is 2. So here's my 2 points as I'm grading your paper. I've shown my work. I've listed my greatest common factor. Now let's say you want to do your Venn diagram instead to find your greatest common factor and just multiply that center oval part. That's showing your work as well. I will take either one to be able to get credit. Once I've shown my work in one way or the other, then I'm going to put a 2. I personally find that this is the easiest way and also the easiest way for most students to understand. But either way of showing your work is going to be counted. All right, so now I go to question 3, which is 25 and 40. I'm going to do the same thing. I'm going to list my factors. So I have 25. So I have 1 and I have 25. Now, here's where you have to stop. And this is where I want you to do a self-check. Are you following along? Are you paying attention? Are you thinking about mentally what we're talking about as we're going through it? Maybe trying to work through it before I even get to the answers so that when I get them down, you're checking your work. Or are you disengaged with me? You're not really focused and you're just waiting for me to have the page filled out so you can write them down. The problem of just having things written down is when it comes to you doing your homework, especially if you run out of time here and you have to take it home, I'm not at home to help you. And then you'd probably end up having to watch the video again at home, which is fine. That's why it's here. But if we do it once and you're truly engaged and following along and listening to me, then you're going to get it because we do so many repetitions. So hopefully you're engaged, you're following along and filling out. I have 25, I have my smallest factor. Now I'm ready for my largest factor. My largest factor has to be 25 because that's the number we're talking about. Now I do my counting numbers. 2. Well, 1.1a said that it would have to be an even number, and it's not, so 2 doesn't work. 3. Well, 2 plus 5 is 7. 3 doesn't work. 4. 4 does not go into 25. It's not one of its multiples. 5. 5 works because it has a 5 or a 0 at the end. So I know it's 5, and it would be 5 times 5. Now, I, once again, only list it 1 time. If you want to list it twice, that's fine. I won't count it wrong. Okay, but I just don't want it to cause any kind of confusion. But once I get there and I've repeated that number, then I know that I have them all listed. So 25 only has 3 factors. So now I'm going to do the same thing with 40. 1 and the largest number has to be 40. Then I go through my counting numbers. It's even, so I know 2 will. How many times? 2 goes in 20 times. 3. Well, 4 plus 0 is 4, and 3 does not go into 4 evenly. 4. Absolutely. I just added a 0 at the end, right? So I take my 4 and my 10. That's the multiple rules of 10. 5. It ends with a 5 or a 0, so yeah, 5 will work. How many times? Well, 5 times 8 is 40. 6. 6 doesn't work. It only goes up to 36, and then I pass it. 7. 7 doesn't work either. 8. 8 is listed. So once I get to a number that's listed, I know I have them all. Now I have to look at comparisons and find the greatest common factor. And once again, 25 only had 3 factors. And 25 is not listed below, but the 5 is. So that tells me that the 5 has to be the greatest common factor. So 2 points. You showed me your work either with a Venn diagram or by making your list of factors, and then I have my 5 as my answer. So 4 and 5, same process. I'm going to go a little bit quicker, but if I go too fast, then just pause the video and make sure you can get caught up. So I'm going to do 24 and 40, and I'm going to list the factors. I'm going to start from my smallest to my biggest. So I'm going to have 1 listed, and my biggest on 24 has to be 24. It's even, so I'm going to have 2, and 2 goes into 24 12 times. 3, 2 plus 4 is 6, and 3 does go into 6 evenly. So I know that 3 is a factor. 3 times what? Well, 3 times 8. And then 4s, if I know my multiplication facts, I know it's automatically going to go into it. And 4 times what? 4 times 6. 5 is my next counting number, which doesn't go into it because it doesn't end with a 5 or a 0. 6 is already listed, so I know I've included them all. Doing the same thing for 40, I have my smallest, which is 1, and then I have 40 because it has to be my biggest. It's even, so I use 2. 2 and 20 make 40. 3, 4 plus 0 is 4, and 3 doesn't go into it. 4, yeah. Now, as I'm going through, these sound really familiar, and if I look back over here, I already have them listed, don't I? So if I just go ahead and copy them over, I end up with my completed list. Once I've done that, now I look for the greatest one that they have in common. I usually start with my smallest number and just look at the bottom, see if it matches up. 24, it's not there. 12, no. 8, 8 is there. So 8 is going to be my greatest common factor. Now on 5, what I would like you to do is I would like you to do 5 on your own. That's new to my videos, but as you'll see later on all my other videos that I've already made, I always ask you to do some on your own and just practice so you can check to make sure that you are following and understand what we're doing. So pause the video, solve for the greatest common factor on number 5, and then we'll check your work. So now hopefully you do have something written down, you have work and you have an answer, and now we're going to check it. So if I do question 5, then I'm going to, that should not be a 5, that should be an 8. Number 14, then I have my factors. So you should have had 1 and 14, 2 and 7, and then that's the only factors that it has. Then you went to 35, and you did 1 and 35. 2 doesn't go into it, 3 doesn't go into it, 4 doesn't go into it, but 5 does, 5 times 7. And then you would have seen that 7 was your greatest common factor. So that should have been your answer. Do you have it? I hope so. If not, let's look and see and figure out why you don't. So then that takes us to the second half of the lesson, which is the distributive property, that new thing. All right, so we have to find the greatest common factor between the two numbers, and then we're going to take it out and leave what is left inside of parentheses. So as we work through it then, finding the greatest common factors. We have to find the greatest common factor of 21 and 28. So on 21, I know I have 1 and 21. It's not even, so 2 doesn't work. 3, well 2 plus 1 is 3, and 3 does go into 3 evenly. So I know 3 times what? Well, 3 times 7 is 21. And if I don't know my multiplication facts, once again I take my handy dandy calculator and just type it in. 21 divided by 3 equals, and I see that it is indeed 7. My other counting numbers do not work, and then I would get to 7, and it is there. Now 28, doing the same thing. I have to start with my smallest and my largest, so I have 1 and 28. It's even, so I have to include 2, and that would be 2 times, well that would be 14. And then 3, 8 plus 2 is 10, and 3 doesn't go into it, no. 4, well I know 4 times 5 is 20, plus 4 is 24, plus 4 is 28. So yeah, 4 would have to go into it evenly, right? How many times? Well, 4 times 7 is going to be 28. 5, no. 6, no. 7 is already there. So my greatest common factor is 7, and I have to identify that first in order to do my distributive property. So once I know my greatest common factor is 7, then that's what I'm going to take out of both of those. So I write my 7 by itself, and then I have to figure out what is left. So that's when I have to know my multiplication facts, or I could type in my calculator 21 divided by 7 and see what's left. 28 divided by 7 and see what's left. I'm going to have my 7, and then I'm going to have my parentheses. And what I find out is left inside my parentheses, there would be a 3, because 7 times 3 is 21. And there would be a 4, because 7 times 4 is 28. The addition stays there that was in the original problem, and it just goes in between them. So my greatest common factor comes out, and then I put parentheses, and then I fill in the parentheses with how many times that greatest common factor will go into my whole numbers. My answer says to express the sum as a product, and this indeed is a product, because a product is the answer to any multiplication problem. And this tells me that I'm going to be multiplying as my last step. All right, we'll try it again. So on 7, I have to find my greatest common factors of 15 and 27. So I start with my smallest and go to my largest. I have my 1 and my 15. 2 won't go into it's not even, but 3 will, because 5 and 1 is 6, and 3 goes into 6 evenly. So I know 3 times what? Well, that's 3 times 5, right? So those would be my factors for 15. 27. So I have 1 and 27. 2, nope, it's not even. 3, 7 plus 2 is 9. 3 goes into 9 evenly, so 3 has to be a factor. So I have 3 times what? Well, 3 times 9. 4, no. 5, no. And I would go all the way up until I got to 9 and realize that that's my last factor. What does it have in common? Well, it has 1 and 3 in common, but the greatest in common is the 3. So that's going to be my GCF, and that's what I want to take out of these two numbers. So for my original problem, I write it down, and then I want to show that I'm taking a 3 out. And that's what I'm going to have on the outside, and then I'm going to set up parentheses and figure out what's left on the inside. So when I know that I have 3 on the outside, then what's left? Well, what's left is I have a 5, because 3 goes into 15 5 times. And what's left for 27? A 9, because 3 goes into 27 9 times. So I have in my parentheses 5 plus 9, and then I have my multiplication of my greatest common factor of 3. This is a product type question because I know I'm going to have to multiply at the end, so that is my answer according to the distributive property. All right, so what about 8? Doing the same thing. Have to find my greatest common factor for 40 and 15. Starting with my largest, going to my biggest. So I have 1 and 40. It's even, so I have 2 and 20, because 2 goes into 40 20 times. 3, 4 plus 0 is 4, 3 doesn't go into it. 4, yeah, remember we did this up above? So I have 4 and 10. 5, yes, because it ends with a 0 or a 5. So 5 times 8, and that's all of them that will go into 40. 15 then, well, on 15 it's listed right here, so I just have to copy them back down. 1 and 15, 3 and 5, and then I have them all. Now, 15 only has, once again, I check with my smallest one to check my biggest one, only has 4 of them. 15 isn't up there, but 5 is, so I know my greatest common factor, the number that I'm going to distribute out, is going to be the 5. So when I take my 5 out, and I know I'm left with parentheses, well, what's going to be left in the parentheses? That's going to be left with how many times 5 goes into each of those numbers. 5 goes into 40 8 times, and 5 goes into 15 3 times. So I'm left with my 5, the parentheses, and everything that's left. 5 went into 40 8 times, and kept the addition sign that's already there, and then 5 goes into 15 that 3 times. That is my product answer for distributive property. 5 times, in parentheses, 8 plus 3. Now, as I asked on the previous practice problems, I want you to try number 9 on your own and check your work. So pause the video, work it out, and then come back and continue on. So I hope at this time you have greatest common factors listed, and you've showed me that you've distributed out from the original addition problem. When I find my greatest common factors between 32 and 20, then my factors of 32 you should have listed were from the small one, 1, and my largest 32. And then I had 2 because it was even, and I get 16. 3 doesn't work. 4 does, because it's 4 times 8. And then on 20, then you would have done 1 and 20, 2 and 10, 4 and 5. Then hopefully you saw that your greatest common factor between those two is 4. And then you looked at, well, I have to distribute the 4 out, so it goes off by itself. And you saw that once I did that, in parentheses, I'm left with, well, 4 goes into 32 8 times, and 4 goes into 25 times, and you kept your addition sign. So you end up with your answer as 4 times, in parentheses, 8 plus 5. So if you didn't get that correct answer, then rewind it a little bit and rewatch how I got that answer and see where your mistake might have taken place. So here are some extra problems that you can do, and if you don't get one or the other, please come back and ask, and I'll work with you and help you practice this to where you're comfortable with it before you start your homework assignment. So this is the second longest video that you've had this year, but it was a lot of information, especially learning how to do that distributive property. But your assignment is page 27 in your big book. Questions 2 through 11, remember, they always do number 1 for you as an example. And then we have page 28, 1 through 6. 1 and 2 are going to be reviewing this lesson, and then 4 through 6 are going to be reviewing the things that we've already done so far in this year.